Lesson 7 is properties of logarithms, and in 7.1 we're going to learn about the product property and the power property. And before we get into the product property of logarithms, I just want to review the product property of exponents. So in the upper left corner, you'll see product property of exponents, and the formula itself for it is if we have like a to the m times a to the n, so we have two powers that have the same base, a and a, then we can condense it by adding the exponent. So it's simplified down into a raised to the m plus n. So anytime you have two bases that are the same, in this case a and a, you can condense it down, and they're being multiplied together, you can condense it down into like adding the exponents together. So for like kind of an example that has a little bit more numbers in it instead of dealing with just like only all variables, it's down here. So x raised to the 5th times x raised to the 8th. If I wanted to simplify that, I could just take the two exponents and add them together, x raised to the 5 plus 8, and then that would simplify down to x to the 13th power. So anytime you have multiple powers, like something raised to an exponent, that are like being multiplied together, like these are here or right here, then you can condense it down into just one power, like one base, by adding the exponents. Okay, so moving over to the product property of logarithms. So these properties play off of each other because logarithms are exponents. So in this case, it says log base b of x plus log base b of y is equal to log base b of x times y. So in this case, we have like two logarithms that are being added together. When there's two logarithms that are being added together, assuming that they have the same base, in this case they're both base b, then we can condense it down into one logarithm of like the product of what we're taking the log of. So like we were taking the log of x, we're taking the log of y, we can condense it down into the log base b of x times y. Okay, so moving on to example 1, it says simplify log base 4 of 16 plus log base 4 of 64 using the product property. I think seeing it with like actual numbers kind of helps it click a bit more. So log base 4 of 16 plus log base 4 of 64. So the product property says that if I have like two logs that have the same base, these are both log base 4, then I can condense them down into like a single logarithm. So it'd be log base 4, and then I would take the product of what I was like taking the log of, so it'd be of like 16 times 64. And then from there I can go ahead and multiply those together, so log base 4 of 16 times 64 is 1024. And then I just kind of want to like take each of these logs and replace them with their like actual value, like if we were to simplify them or evaluate these logs, just to help it make a little bit more sense. So log base 4 of 16 is saying like 4 to what power equals 16. So that's 2. Like if we were to simplify or evaluate log base 4 of 16, it'd be 2 because 4 to the second power is 16. And then log base 4 of 64 is like 4 times what power equals 64, and that's 3. So this would simplify to 3. So this is saying like 2 plus 3, since 4 to the third power equals 64. And then over here, log base 4 of 1024 is saying like 4 to what power equals 1024, and that's 5. 4 to the 5th power equals 1024. So even if we kind of like take out like all the logarithms or evaluate them all, like we still should have something that is like true and makes sense. So really like what we have is 2 plus 3 equals 5, which is correct, which is why the product property works, and it'll always work out that way to where you're ending up getting like something that's true. So example 2, Joe wants to rewrite log base 5 of 82 to the third power without the third power. Use the product property to do so. So we want to try to figure out a way to rewrite it without this third exponent up there. So we're actually going to use kind of like the product property in reverse order from the way that we did example 1. So log base 5 of 83. The first thing I want to do if I want to get rid of that third power is I kind of want to just like expand out the 82 to the third power. So 82 to the third power, that means 82 times 82 times 82. So anytime you have an exponent that's saying like how many times you're multiplying the base by itself, so 82 to the third power would be like 82 times itself 3 times. And then if we have like the log of like 3 82s being multiplied together, then we can use that product property in reverse to separate it into 3 different logarithms. So like for example up here, how we had like a log of 16 added to a log of 64 and we condensed it down into like just a log of 16 times 64, we can do kind of the reverse of that and separate the log base 5 of 82 times 82 times 82 into 3 separate logs of 82 that are being added. So log base 5 of 82 plus log base 5 of 82 and then plus log base 5 of 82. So that's applying that product property. It's just doing kind of like unsimplifying it almost, where normally we would take like 3 logs being added together and condense them down into like the log of all the products. But we're expanding it out. And then now anytime you have like the same thing being added to itself, we can think of this as like 1 log, 1 log, 1 log. So we have 1, 2, 3 log base 5 of 82s. And then what this does is it kind of builds into our next property. So if you look like the 3 that was an exponent and it ended up being a 3 that was like kind of out in front, and that wasn't really just like a coincidence that they both ended up being a 3. There is a power property that tells us that if we have like basically a log that's being raised to an exponent, we can take that exponent and we can turn it into a coefficient that's like kind of a number out in front. So log base 5 of 82 to the third power is equivalent to 3 times log base 5 of 82. So that brings us to the power property for logarithms. The formula for it itself is if I have log base b of x to the y, that equals y times log base b of x. So what that's saying is if I have like an exponent over like what I'm taking the log of, I can take that exponent and I can turn it into a coefficient, like a number out in front. The rest of the log would stay the same. So like this is log base b of x, and so is this. The only thing that changes is that exponent turns into a number in front. Okay, so example 3, use the power property to rewrite each log. So in A, it's log base 9 of z to the 5th power. So in this case, my exponent is 5. So that's just going to kind of get basically brought to the front and get rewritten as a coefficient. So this would be 5. And then the rest of the log would stay exactly the same. So it'd be log base 9 of z after that. So log base 9 of z. So 5 times log base 9 is z for that one. And then for b, it's ln, which remember is natural log of 12 to the x power. So in this case, our exponent is x. That's going to get brought around the front to become a coefficient, and then the rest of the log will stay exactly the same. So it'd be x out in front, and then times the natural log of natural log of 12. So it'd be x ln or x natural log of 12. Okay, so for the power property, anytime you have just like an exponent over what you're taking the log of, you can take that exponent and like kind of bring it to the front. And sometimes it just makes the like logs easier to simplify. 7.2 is the change of base formula, and the change of base formula is something that like it's really important, and it does kind of make more sense, and I would say like an in-person climate where you are kind of like you don't have access to like every single calculator. So I know in like a previous lesson we used the GeoGebra calculator where you could like kind of type in any base that you want, but on most calculators you don't have that option. You only get to use common log or natural log, and that's where this is like a really important formula to know. So the change of base formula allows you to convert any logarithm into something that can be evaluated on a calculator, even just like a phone calculator. So for example, you can't evaluate log base 305 on a scientific calculator, phone calculator, anything like that, because you can't choose a base. There's very few calculators out there where you actually can choose your own base on. On most calculators, you'll only have the option for a common log, which is just like the regular log button, LOG, or they'll have an option for natural log, which is the LN. Okay, so most won't have like a little section at the bottom right where you can actually like kind of type in the base that you want. Okay, so for the change of base formula, the way that it works is you can rewrite any log as kind of like a fraction, like a quotient, and choose whichever base that you want. You just have to follow a specific pattern. And when I say like choose whichever base you want, you're usually going to change it to like a common log or a natural log so that you can put it in the calculator. Okay, so there's two different ways that we can kind of approach it, and you always have the option between the two. You'll end up getting the correct answer either way. So first one is if I have log base b of x, I can change it. So I have like a kind of generic base. It's not common log, it's not natural log. The first option is I can change it into logs that have a common log. And I would do that by taking kind of like the big number, like what we're taking the log of, and that would go in the numerator. So it'd be like log, common log of x. And then the original base is going to be what we're going to be taking the log of in the denominator. And then notice both of these got changed to common logs. So as long as we have like the same base on the numerator and denominator, so both common log, this works. So for example, if I were to do like, I don't know, I'll take the same log base 3 of 5 from up above, and I wanted to actually be able to put that in the calculator, I would put log of 5, because that was the bigger number, the one we were originally taking the log of, over log of 3, the original base, and then now that's something that I could put in the calculator because it's a common log. Okay, and then the second option is you don't have to change it to common log, you could change it to natural log, and it'll end up being the same exact answer. It really just personal preference, I guess. So if I started with log base b of x, I would change it to natural log of x over natural log of b. So the pattern works the same way regardless of like what base you're changing it into. The like bigger number goes on the top, and then the like smaller number, the original base, goes on the bottom in the denominator. So if I were to change like say log base 3 of 5 into using the change of base using the natural log form, it would turn into ln of 5, because that was originally what I was taking the log of, over ln natural log of the original base 3. So pretty much it changes the same way, it just, you can pick between the two bases. You can pick between common log or natural log as long as it's the same on numerator and denominator. So next we're going to prove the change of base formula. So in order to do that, we're going to start off with those formulas that we were using when we were first learning to convert between log and exponential form. So I have log base b of x equals y, and then the exponential form of that is x equals b to the y. And remember that the base of the log will match the base of the exponential. And then in log form, the variable that's by itself, in this case the y, ends up being the exponent from exponential form. So they're the same value equation, they're just in different form. And then in order to prove the change of base formula, we're going to work off the right side, the exponential side. So the first thing I'm going to do is I'm going to log both sides. I'm just going to use a common log. You can use a natural log, you could technically use any log to prove it, but I'm going to log both sides. So it'd be log of x equals log of b to the y. And then we just learned the power property that says like if we have an exponent over what we're taking the log of, we can turn that exponent into a coefficient. So this would become log of x equals y times log of b. And then now I just want to get y by itself. So that like log of b is being multiplied by y. So I'm going to divide both sides by log of b. And then I have log of x over log of b equals, and on this side, the like log b divided by log b cancels out. So I just have y. And then all the way up here, we said that y was equal to log base b of x. So that means that instead of having like a y there, I can just put log base b of x there because those are equal. So I'm just going to take out that y. You can write it in a second line if you want, but I'm just going to take out that y. My eraser was really big, sorry. Take out that y and put in the log base b of x. So this is exactly what the change of base formula was. We just kind of wrote it in reverse order. That's how it ended up. But it was log base b of x equals log of x over log of b. And then same kind of like ordering where what we were taking the log of ended up in the numerator and what the base was ended up in the denominator. Okay, so example 1, evaluate each log using the change of base formula. So this one just has 2 problems. They're both pretty quick. So A is log base 11 of 65. So I'm going to use common log for one of them and then natural log for another one. You can use whichever one you feel more comfortable. But for change of base formula, if I want to use common log, I'm just going to write them both in right away. So that's the base I'm going to use. And then the only other thing is I just have to remember what number goes where. The bigger number is going to go in the numerator, like not like the larger quantity, but like the one that's physically written bigger, like 65 is typed in a bigger font than 11. So what we're taking the log of, that like kind of written bigger number, that goes in the numerator, it's 65. And then the original base, the like little tiny number, will go in the denominator, and it'll always kind of follow that order. So it'd be log of 65 over log 11. And then once we get it into this form, this is just kind of like a calculator-based problem. So I'm going to cut over to the calculator. So we had log of 65 over log 11, so we do log of 65, and then as long as you close the parentheses, you can just do this all in one step. So you do log of 65 and then close the parentheses, and then divided by, because that's what fractions are, is like numerator divided by denominator. And then you do have to type in log again. So log of 65 and then divided by log 11. So it's about 1.74. And again, it's really important to remember to like after the 65 close out the parentheses. If you do it differently, you'll get a different answer. And I just want to show you like really quickly how if I had done the natural log instead of the common log, it would have ended up being the same answer. So it'll be natural log of 65, close the parentheses, and then divided by the natural log of 11. And it's the same exact answer, about 1.74. Okay, so log of 65 divided by log 11. Log of 11 was about 1.74. And then for B, log base 83 of 49,711. Obviously don't have a log base 83 button on just like a generic calculator, so we're going to use the common log to change this one as well, so that it is something that we can find on just like kind of a more generic calculator. I think I'm going to write this one just like kind of below so I have a little bit more space, but it's log base 83 of 49,711. So using the change of base formula, I just have to pick whether I want to use common log or natural log. I'll use natural log for this one just so we have an example of both. And then what we were originally taking the log of goes in the numerator. So 49,711. And then the original base goes in the denominator. So it has to be natural log down here as well. You couldn't like do one common log, one natural log, but it'll be natural log of 83. And then once you get it in this form, then you can go ahead and just put it in the calculator as is. So it'll be natural log of 49,711 over natural log of 83. So natural log of 49,711, don't forget to close the parentheses, and then divided by natural log of 83. Oops, too far. 83. So it's about 2.45 5 if we round. So if we look at the third number after the decimal, that 7 would round the 4 up to a 5. So 2.45-ish. And then same thing, I'll just type this one in like the common log as well to show how it's the same thing. So if I use common log, it'd be common log of 49,711, close parentheses, and then divided by common log of 83. And we end up getting the same answer, about 2.45. So natural log of 49,711 over natural log of 83 ends up being about 2.45. Okay, so whenever you have just like a log of any random base, you can always evaluate it in a calculator. You just, most of the time, if you have a regular calculator, you have to put it in kind of a different form using the change of base formula. So this formula really comes in handy.